Thank you everyone for joining. I'm Sukanya, Senior Integration Engineer from Neon EVM. Today we are going to showcase how you can access Solana using Neon EVM, using your own Solidity smart contracts without writing anything in Rust. So first of all, let's just get to know what Neon EVM is. So Neon EVM is basically a smart contract on Solana. In Solana, the smart contracts are called programs. So Neon EVM is a program on Solana which can execute EVM bytecodes inside Solana's virtual machine. So we are basically not a layer 2 or not a bridge. We are just inside Solana's virtual machine. And Solana can have like executable files up to 10 MB. And like EVM is, I think, around like 2 MB or something like that. So it can embed the whole EVM into it. That's how like Neon EVM is. And with Neon EVM, like you can have all the benefits from the EVM ecosystem, like all the Ethereum tooling, which is already there. You can have like all the Ethereum tools for the development, like Hardhat, Foundry, Remix, and also like you can use the already existing wallets like MetaMask, and we also have integrated Trust Wallet. And also like we have all the RPC methods available, which are already in Ethereum. So you can also use all of them. Those are all compatible with Neon EVM. Also like you can get the benefits from Solana, which is basically the low gas fees, high transaction speed, and the most important thing is the parallel execution. So we were live since last July 2023. We have like all these components of Neon EVM. So this is EVM, which is basically the Neon EVM program. Then we have the proxy server, which is the main integral part of the like the transaction that happens, because proxy server is the thing which like gets the Ethereum-like transactions, does a simulation, and converts it into a Solana-like transactions, and then pushes it to the Neon EVM program. Then we have the Tracer API for debugging. Then we have Neon Pass, which is our native bridge from like Neon EVM to Solana and vice versa. Then we have Neon Faucet for the development. You can get Neon DevNet tokens from there. Then we have the Neon DAO, which is the owner of the Neon EVM program. Then in theory, like we can like go up to 2000 TPS, and like the transaction fees, like you can already see, like it's like very low. Yeah. So this is basically the ecosystem. We have all the wallets like MetaMask, Ledger, we have integrated. Then we have Trust Wallet, Gnosis Safe. Operators, we have 2 operators, P2P and Everstake. Then we have Explorers, Block Scout, and Neon Scan. Indexes, Graph, Subsquid. We have Oracle's Chainlink, Bit. Then we have the NFT tool, which is from Solana, which is Metaplex. Then we have our own bridge, native bridge, that is Neon Pass. And we also have dBridge integrated with us. We have a lot of DeFi protocols already deployed on Neon since last we launched in the July last year. So we have lending borrowing protocols like LendOS, Lumen, and we have a lot of other DeFi protocols as well. Like you can see on the board, like it's Ice Cream Swap, like Uniswap V2 fork on Neon. We have Vibrant Finance, Mora Swap, Lever Finance, and lots more. Then we have also like a lot of NFT and gaming platforms right now already deployed. You can see all the list there, that Versus X, there is Battle Dogs Arena, and like some more. And we have Launchpads, which is MinPad and Pixelrium, which are in deployment stage. And so we have all the developer frameworks, which are already available, Hardhat, Foundry, Truffle, everything, which is compatible with Ethereum. And all the SDKs and APIs as well. So, yep. These are the development tooling, already known development tooling in the EVM ecosystem. This is basically the Neon EVM architecture. So whenever like you have a front-end dApp, which is using a MetaMask wallet to sign transactions, you can have a Ethereum-like transaction Then it goes to the proxy, which is inside of our operators who runs the proxies. The proxy basically provides an Ethereum RPC API to connect to it, and then it interacts with Solana to just convert the Ethereum-like transaction, does a simulation, and then it converts it into a Solana-like transaction, and then sends it into the Solana's virtual machine, inside of which our Neon EVM program is there, which can execute the bytecodes. So this is how like the Neon EVM architecture looks like. So basically, Neon EVM program, just to let you guys know how like a Solana's architecture is, because Solana is a little bit different than Ethereum. It can't store, the programs can't store any data, so they are stateless. So everything is stored in accounts. So you can see like the Neon EVM, which is basically a program, which is an executable program. It has a Neon account, which is like you can have a Neon account like your Ethereum account, which can store which is a program derived address, like from the Neon EVM program. It is a derived address for your Neon wallet, and it can store the data. Like the program itself cannot store data. So Solana is stateless. So this is how like it works. So this is the basic knowledge about how accounts are created and stored in Solana. So this is how a transaction goes through. This is how a transaction is packed into a Solana-like transaction. So you can see that the Solana transaction is a completely different one. You need to have the account list, and that account list is basically the list of all the accounts like you need to access when you are executing a transaction. Like you have an Ethereum transaction, and that transaction can access different accounts, like different data accounts in a same transaction. So you have to have that account list in the Solana transaction inside the proxy. And this is how like whole Solana transaction looks like. You can see like you have the address of the Neon EVM program, then the list of Neon accounts, contracts, and the data accounts into the account list. Then you have the index of the Neon EVM program into the program index. And all the Ethereum-like transaction data, which are the nonce, gas price, and value and the data, everything goes into the data field. This is the parallel execution, which is basically of Solana's main like feature. So Solana can execute transactions in parallel. So this is basically we are today, like before going into the bounties or talking about how to access the Solana into like going through the tutorial, we just want to like get you guys know like what the composability feature of Solana is. So basically Solana has the feature of like you can call like from a program, from a like Solana program, you can call another Solana program. So this is called the composability feature, which also has the cross-program invocation, which is basically like invoking instructions of a different program from another one. So this is how like our bounties are also today about. Like we are looking for like some kind of projects which are surrounding this composability feature. So it actually happens like the Neon EVM, you have a Neon EVM address, and you will have a Solana interface contract on like in Solidity, which can call an already existing precompile inside Solana's virtual machine. And that precompile has all the like the required functions which you need to call from the Solidity contract. So you can have the interface, and from that interface you can just call those methods. So this is how like it looks like. So we have the iCall Solana Sol contract, from which you can call the precompile, which already exists on SVM. So these are like some of the bridges we have, like Neon Pass and Debridge and some other EVM chains. And yeah, just before going into the tutorial, I just want to like give you an insight of our incoming features, which are the multi-gas payment feature. Like we are experimenting with it, and most probably we'll be launching it soon with the multi-gas. Like you can pay right now when you do a transaction, you can pay only in the native token Neon. But we are experimenting with it, and we are trying to do multi-gas payments. Like you can make payment with Sol, you can make payment with any other ERC20 tokens. So yeah, let's go to the tutorial first and just check it out how to access Solana. You can get the RPCs from just chainlist.org. Type Neon EVM and you can get the Neon EVM mainnet and Neon EVM devnet chains from there. Then, okay. Yep. So just as I mentioned already about the composability feature, so from Solana you can access Solana's from Neon EVM you can access Solana's liquidity. So you can, from your smart contract on Solana, on Neon EVM, you can just do a kind of swap on any DEXs which are already existing on Solana. Like you can do a swap on Orca, you can do a swap on Radium or Jupiter. So I'm just going to show you guys like how this works on Neon EVM, how you can access from Solidity contract, you can do a swap on Solana's DEXs. As I have already mentioned about the I call Solana interface contract. So this is how the interface contract looks like. So we have like the instruction struct and the account meta struct, which is basically used when we are building an instruction that is passed to the Solana's transactions. So this is how the struct looks like. Then we have like the following functions. The Neon address, you can just pass any Ethereum Neon address which is there and just get the Solana address from that. Then we have some useful methods like execute and batch, execute and then execute with seed. So these functions are necessary when we are executing transactions, when we are passing the transactions to Solana. So we will have to use these execute functions where we are passing the instruction and lamports. Lamports is the smallest unit of Sol on Solana. So these lamports are used when we have to have a payer for a transaction. So all the transactions doesn't need signing, but some of the transactions need signing. So for that signing purpose, we have to have some lamports for the payer. So this is how like we pass the lamports to the execute function. So here we have a config file. Like these tutorials are already available in our docs website. So you can go and just check it out there. We have a GitHub tutorial as well. You will find all the links there and you can just build like whatever like you can with that. So you will find all those stuff. But yeah, just to let you know that we have a config file here where we have already written all the useful functions that will be useful for doing a swap on Orca, Radium, or Jupiter. So it's already written there. So there are some of the functions like the execute or like the prepare instruction accounts, like how to prepare all the instructions for the Solana transaction to happen. Then we have this contract, which is basically the contract which has all the functions for like a swap on Orca, for a swap on Jupiter, and a swap on Radium. So I have this function already, which can be called through our script, which I will run in a few minutes. So this is a script which is batching two transactions. One is a swap on Orca and one is a swap on Radium. So I can just run it and show it to you guys. So Radium has a doesn't have a dev environment, so that's why we need to do it on mainnet. So I'll just run the script. I think something is not Just a moment. Yeah, I think there is. Yep. Yeah, now we can see, we'll be able to see how the transactions is broadcasted to Solana from Neon EVM. It may take a little bit of time, guys, because mainnet sometimes like it takes a little bit of time, but yeah. Yep, you can see that the approval of Rapsol. So this is a script where we are swapping Rapsol with USDC on Orca and Radium both together. Yeah. Sometimes querying the Radium pools take a little bit of time. So I can just show you guys one more transaction till it happens so that we have this. Yep. So this was a transaction that was done last night. So this is basically a Rapsol to USDC swap on Neon EVM. You can see there are 7 transactions. We have like 7 Solana transactions. So why this is split up? Because the Neon EVM transactions sometimes are big enough, and it cannot fit into one Solana transaction at a time. So that's why like the proxy, it splits the transaction into smaller transactions so that Solana can fit into it, and it just does the iterations like that. If you can click on the last transaction, you can just see that we had an interaction with the Neon EVM program, and you can see the swap happening on Radium and a swap happening on Orca as well. So in the last transaction, you will get all the aggregated data of all the transactions. So this is how it happens. And yeah. So let's see if it has gone through. No, I think Radium is still taking time. But yeah, it's fine. I think I can just show you the Jupiter one then very quick. Yeah, Jupiter should go on real quick. Sometimes Radium pooled data, like it takes a lot of time to process. So yeah. So with this script, this is a Jupiter swap script. So here we are swapping USDC and USDT. I already have a transaction happening like this. So this is another transaction which happened 3 days back on Jupiter from Neon EVM. This is a swap from USDC to USDT. It's the same thing. We have 3 Solana transactions split into like one Neon transaction split into 3 Solana transactions. And the last transaction can give you the details that it is interacted with Neon EVM program and the swap happened on the Jupiter. So let's see if it has gone through. I think no, because it's mainnet, so it takes a little bit of time, guys. Yep. Let's see our bounties then for now, like just to let you guys know. Yeah, so these are our bounties for regarding the composability. So, yeah. You can just build anything surrounding composability feature, like if you can have like any cross-chain DeFi aggregator or real farming, which you can like deploy on Neon EVM and then access it on Solana, like using the composability feature. Anything you guys can do with it. And we also have a bounty about developer toolkit or SDK libraries that will be easily that will be easy for developers to get access to Solana. So these are our 2 bounties for this hackathon. So yeah, just go through it, guys, and I hope you build something good on Neon EVM. Yeah. I don't know like why this mainnet is not working, but yeah, I think it's worked. It worked. Yeah. So I can just show you a little quick. Okay. Yeah. Okay. Thank you so much. Thank you so much, guys. Yep. Yeah, sure.
You show the execute function. Do you have any function which is meant for viewing the state rather than executing something on Solana?
I didn't get your question. Yeah.
So you want to use the microphone?
Yeah, so do you have any other function other than execute which allows you to view the Solana state rather than executing something on Solana?
No, I think we don't have like that function because these functions are already in our precompile, and I don't think so we can get a state from Solana.
We have another precompile which is called read Solana, which actually you can read any account data. This is how we actually read price feeds, basically Solana cherry price feed, big price feeds, we read directly from Solana. So you can read any data from Solana, you can read it through our precompile. So we have a precompile to execute, we have precompiles to read.
To read, yep.